Hello everyone, my name is Krishna Moite and today I will be teaching the concept of multiplexing from data communication. Imagine this, hundreds of people are trying to use the same road at the same time. What happens? Traffic jam, right? Exactly. The same problem happens in communication networks. So, how do multiple devices share a single channel efficiently? That's where multiplexing comes in. And today we will understand in a super simple way. In this video, we will cover what is multiplexing, why we need it, its type, FDM and TDM, and real-life application and its advantages and disadvantages. Now let's begin. Think about your mobile network, Wi-Fi, or even the internet. There are millions of devices are sending data at the same time, but the communication channels are limited. The problem is there are too many users, limited bandwidth, expensive to give each user a separate channel. So instead of creating a new channel, we share one channel smartly. And that smart technique is called multiplexing. Multiplexing is a technique where multiple signals are combined and sent through a single channel, then separated at the receiver. We use MUX and DEMUX. As you can see in the diagram, the MUX combines multiple signal and sends through one link to the DEMUX as a input, and it use n output lines. So basically, it is a many-to-one communication system. There are different types of multiplexing techniques, but in this presentation, we will focus on two main types, frequency division multiplexing or FDM and time division multiplexing or TDM. Let's start with FDM. In frequency division multiplexing, the bandwidth is divided into different frequencies. Each user gets a unique frequency and all our users transmit at the same time. Its best example is FM radio. We know that each radio station has its own frequency, 91.1 megahertz, 98.3 megahertz, 104 megahertz. They all transmit together, but they don't interfere. Why is that? Because of guard bands, which acts like a gap between frequencies. Now let's understand how FDM works. Each input signal is first converted into a different frequency range. These signals are then combined into one composite signal and transmitted through the channel. Small gaps, which here we can see are called guard bands and are used between frequencies to avoid interference. At the receiver side, filters are used to separate the signal back to their original form. This is why FDM is widely used in radio and cable TV system. In time division multiplexing, instead of dividing frequency, we divide time. The channel is divided into small time slots, and each signal is assigned one slot. All signal use the same frequency, but they transmit one after another in sequence. This process happens very fast, so it appears that all signals are transmitted simultaneously. Let's take an example. Suppose there are four users. User 1 sends data to user 2, then to user 3, then to user 4. This cycle repeats very fast, so fast that it looks like everyone is sending data simultaneously. TDM is mainly used in digital communication systems. Now let's understand how TDM works. First, process. Each signal is assigned a fixed time slot in a repeating cycle. Second process. Signal takes turn transmitting data during their respective slot. Third process. The switching between signals happen at very fast speed or high speed, creating the illusion of continuous transmission. The fourth process is synchronization. The synchronization between sender and receiver is very important. If the synchronization fails, data goes to the wrong user. This technique is widely used in digital telephone networks. Now let's compare FDM and TDM. In FDM, signals are separated using different frequencies and transmitted simultaneously. In TDM, signals are separated using time slots and transmitted sequentially. FDM is mainly used in analog systems, while TDM is used in digital systems. Both techniques are important and are used based on the system requirements. Now we will see its advantage of multiplexing. Multiplexing provides several advantages. It allows efficient use of bandwidth, reduces infrastructure cost, supports multiple users over a single channel, and it also improves overall system performance by optimizing resource usage. This makes multiplexing very useful in today's more communication systems. Now we will see the disadvantages and design challenge in multiplexing. The system becomes more complex, especially in managing multiple signals. Synchronization is required, particularly in TDM system. There is also possibility of signal interference if not properly designed. So proper implementation is very important. Now let's look at the real world application of multiplexing. We are already using multiplexing in everyday life. It is used in telephone systems, which enables simultaneous voice calls over a single trunk line. It also allows internet transmission, which allows high-speed internet backbones, which relies on optical FDM, carry terabytes of data simultaneously. Third, cable and broadcast TV. FDM assigns each TV channel its own frequency band for uninterrupted concurrent broadcasting. It is also used in satellite and radio. Both FDM and TDM are used in satellite uplinks and radio systems to manage limited spectrum. To conclude, multiplexing is a key technique in data communication. Multiplexing combines multiple signals in one channel, and demultiplexing separates them at destination. FDM dominates analog and optical domains, while TDM is standard for digital voice and data networks. Both remain indispensable in practice. Sorry. Now, why it matters? Without multiplexing, today's internet, mobile networks, and broadcast system would require orders of magnitude more physical infrastructure. So, without multiplexing, modern communication system would not be possible. Thank you for your time and attention. I hope this will help to understand the concept clearly.